All right, we're looking at answers from Friday's assignment, the 5 problems from the book on page 262 and 263. First problem, number 17, it says we have a rectangular page is to contain 30 square inches of print. The, excuse me. Margins on each side are 1 inch. Find the dimensions of the page such that the least amount of paper is used. So when they said the margins on each side are 1 inch, I took that to assume that we're talking about left, right, top, and bottom. So it said the print area has to be 30. So I labeled this piece X. I labeled that piece Y. So X times Y is my area. Said that has to be equal to 30. We want to minimize the amount of paper being used, the total amount of paper being used. So that is area of the total paper. So I've got X plus the 2 edges. So that's where I got X plus 2 from. I've got Y plus the 2 edges. And that's where I got Y plus 2 from. So there's my prime area because area is what we want to maximize or minimize. And then over here, I went ahead and solved for Y. I went ahead and distributed all this, and then I plugged Y in here and there. So this right here gives me 30, plus the 4 that's here gives me the 34. I've got the 2x, and then right here, 2 times 30 over x gives me 60 over x. Take the derivative of that. Derivative of 34 goes to 0. Derivative of 2x is 2. Derivative of 60 over x is negative 60 over x squared. I got a common denominator there. Set it equal to 0, and then looked at the top and looked at the bottom. Bottom is obviously going to give me 0. And the top, I add 60 divided by 2, which is 30, and take the square root. We end up with x equals 30. Makes no sense for x to be equal to 0, so x equals 30 is what we want. So this inside is 30, and plug that back in here. We get 30 over the square root of 30, which is the same thing as the square root of 30. Now let me check the problem real quick. Dimensions of the page. So this would be the dimensions of the inside. So to get the dimensions of the page, I would have to add 2 to both of these. So left to right, it's going to be square root of 30 plus 2. Top to bottom is also going to be the square root of 30 plus 2. So that's number 17. 19. 19 says we have a farmer that plans to fence a rectangular pasture adjacent to a river. The pasture must contain 245,000 square meters. Mercy. In order to provide enough grass for the herd. No fencing is needed along the river. What dimensions will require the least amount of fencing? So they labeled the 2 sides as Y and then the other side as X. So to get the area, it's going to be X times Y equals 245,000. And total amount of fencing, I've got 2 Y's, but I've only got 1 X. So that's why I have 2Y plus X equals the amount of fencing. So this is what I want to minimize. So I come over here, get a variable by itself, X or Y, doesn't make a difference. I got Y by itself, so I plug in here. So 2 times that is going to give me 490,000. Take the derivative. So the derivative of this would be negative 490,000 over x squared. Derivative of x is 1. Common denominator again, set it equal to 0. Bottom's going to give me 0, which doesn't make sense. Top, I add that over, take the square root, which is the square root of 490,000, which is also 700. We plug 700 back in here, and we get 350. So the 2 sides are going to be 350. The third side is going to be 700. So those are our dimensions on number 19. 21. We did this one in class, and I think everybody was in class. So we'll skip over 21. 25. Let me pull that page up. All right, 25. A rectangle is bounded by the x-axis and the semicircle y equals the square root of 25 minus x squared. What length and width should the rectangle have so that its area is a maximum? Okay, so the piece on the right is x, the piece on the left is also x. So this distance and these two distances are the same. And from here to there is x. So that means this whole distance is going to be 2x. Top to bottom is y. So that means this rectangle is going to be 2x by y on its dimensions. So the area is going to be 2x times y. Then they gave me my secondary, which is right here. So we plug that in for y, which is right there. Then we're going to have to do the product rule. So first times derivative of the second plus the second times the derivative of the first. So right here, I reduce those two. So we end up with negative 2x squared. I forgot to cancel it. So that's why that's there. And then over here, I just move the 2 to the front, get a common denominator. And I dropped that down on there for some reason. I need to keep it. So that means the top is going to be negative 2x squared plus 2 times 25 minus x squared. Distribute the 2, which gives me 50 minus 2x squared. So that gives me negative 4x squared. I move the 4x squared over. I divide, so I get the square root of 50 divided by 4, which is 3.535. If I set the bottom equal to 0, that gives me plus and minus 5, which doesn't make sense because if it's 5, that puts me right here and I have no height. So if my width is 5, or if my x value is 5, I have no height. So the not having the bottom there didn't end up hurting me. So we plug x in, we find out that y is that same value. The problem wants the width and the height. So remember, x is only 1/2 of this, so I need 2 of them. So if I take that times 2, that means my width is 7.070 and my height is 3.535. That's 25. And we covered 29 in class. So there are your answers from Friday's work.